In this discussion video, we are going to do some more U-substitution examples. So this is part 3 of our U-sub discussion videos. Alright, so I want to have you first try parts A, C, D, E, and F of this question, which is from worksheet 14. So give yourself 8 total minutes to try those. So pause the video in 4, 3, 2, 1. Pause it and try those for 8 total minutes. Alright, so hopefully you did that. Hopefully you paused it and tried them for about 8 minutes. Let's talk about them. So for part A, I'm going to do a u-sub, and I'm going to let u be x squared. And when I take the derivative of that, my du is 2x dx. And I know that this is going to work out because I see du in my integral just off by a constant multiple. Because I see x here, and I see dx there, and that's my du just off by this factor of 2. And that was one of our tip-offs that this u-sub is going to work. Alright, so now let's rearrange this. Let's get dx by itself. So du over 2x equals dx. And if we plug in, we'll get this integral of x times sine of u. And my dx is du over 2x. So the x's are going to cancel. I can bring the 2 out to get a 1/2 integral of sine of u du. And this antiderivative, we know, the antiderivative of sine is going to be negative cosine. So we'll get negative 1/2 cosine of u plus c. Then we got to plug back in for u, which gives us negative 1/2 cosine of x squared plus c. And that's our answer. Alrighty, let's do part C. So in C, we have the antiderivative of secant squared. So for this, we don't need any u-sub. We know what this is. We know a function that we can take the derivative of to get secant squared. So what was that function? Well, it's just tangent. Derivative of tangent is secant squared. So that means the antiderivative of secant squared would be tangent of x. And of course I got to put the plus c because this is an indefinite integral, which means general antiderivative. And that's it. Okay, so the moral there is, now that we have u-sub, be careful, because not every integral requires u-sub. So we want to remember our old techniques for doing antiderivatives, like, well, what if I just know the antiderivative already? Okay, so let's do part D. All right, so we have the integral of secant cubed times tangent x dx. So this one, we may have to try a couple of things, so that's what I want to do. I want to do this in 2 ways. So in attempt 1, I'm going to let u be equal to tangent of x. Okay, so then du, we already saw that derivative, that's secant squared x, but I got to make sure I write that dx. Okay, so now, if we start to plug in, I'm going to do it in the following way. Let me split up the secant cubed as secant x, and then let me write the secant squared x next to the dx, and then I'll still have the tangent x here. Because now, this whole thing is going to become my du. So I'm doing this without isolating dx. I'm just identifying, well, where is the du in my integral? And I know that the tangent is going to become u. So if I plug in, we get the integral of secant x times u du. All right, so we did this u-sub, but we still have some x's lingering because we got the secant of x. And we've seen that one of our strategies for dealing with that is we could try using our u-sub again. So we could try using u equals tangent of x. Again, I can't use it right now directly because we have secant. So somehow I would need a way to rewrite the secant in terms of tangent. And there is a way to do that if I use a trig identity. But maybe there's just a better way. Maybe there's a better u-sub that would let me avoid any trig identities. Maybe there's a better u-sub. And also in this case, if I were to use that trig identity, it's something that involves secant squared and tangent squared, I would end up square rooting. And when I square root, I'll end up with a plus or minus and a square root. And that's not the nicest thing. Okay, so let's try this a different way. So what if instead we let u be equal to secant of x? Then du, the derivative of secant x is secant x times tangent x. I gotta make sure to write that dx. Okay, so let's try to split up my integral again let's try to separate the secant cubed so I can identify where du is in this. So I'm gonna write secant squared like that, and then I'll put the other secant of x next to the tangent x dx, because now I see that this whole thing is du, and secant squared, well, that would be u squared. So we get the integral of u squared du, and this we can handle. We know this antiderivative is u to the third over 3 plus c, that I just got to plug back in for u, which is, so I'll get secant cubed of x over 3 plus c. And there's my answer. So the takeaway I want to point out from this example is sometimes the first thing that we try in an integral won't work. In fact, sometimes the first or second thing that we try may not work, but we want to be persistent. Okay, and that's what we had to do here. We had to change, what to let u equal, and eventually we found something that worked. All right, let's do part E. So in E, we have the integral of sine x over 1 plus cosine squared x. So for this one, I noticed that if I were to let u be cosine x, I see du in here, just off by a constant multiple, because I see that du is negative sine x dx. And I see that in the numerator here, it's just off by this constant multiple of -1. Okay, so I know that this is going to be a good u sub. Let's isolate the dx. So I get du over negative sine x equals dx. And now let's plug in. So this will give us the integral of sine x on the top. The bottom becomes 1 plus u squared. And dx is du over negative sine x. Okay, so this is nice because the signs cancel. Let me pull the negative to the front. So I get negative integral of 1 over 1 plus u squared du. And I know that that's the arctan. This antiderivative is arctan. So I'll get negative arctan of u, or I could also write tangent inverse of u. And now I plug back in for u to get negative arctan of, what was u? It was cosine x. And whoops, I realized I forgot the plus c on the previous line. Okay, so once I took this antiderivative, I got to put the plus c. Can't just wait till the last step. It's once I've done the antiderivative, I got to put the plus c in at that step. Alrighty, so there we go. That is our answer. Okay, so to end this, let's look at part F. Alright, so F, we have this integral of, this time, cosine x over 1 minus cosine squared x dx. For this problem, if I were to try letting u be cosine x, I don't see du in this integral, because du would have a negative sign, and I don't see any signs in here. So that's a bit annoying. I'd like to have some signs and some cosines so I can see the du show up. So to get that, I'm going to use a trig identity. I have cosine x on the top. The bottom, if we use the trig identity, sine squared x plus cosine squared x equals 1. The bottom, 1 minus cosine squared, that's just sine squared x. So the bottom is just sine squared x. And now this is really nice for a u sub. If I let u be sine x, then du would be cosine x dx. And from here, it's going to be really nice. So I'm actually going to leave this for you now. I'll put a dot, dot, dot. And I'm going to leave this as a practice problem for you to finish.